portfolio with the high return is portfolio A with 100% MBB. And look at the standard deviation, the risk. Yeah, the portfolio with the lowest risk, where? Not portfolio A, also not portfolio E. Is this portfolio? Yeah, portfolio B, 11%. Yeah, and look at the single standard deviation of GMDF and MBB. So if within the two financial assets, MBB had lower standard deviation or lower risk, only 11.41, yeah, percent. But when we combine GMDF with MBB, the risk of the overall portfolio is 11%, even smaller than the risk of MBB itself. Yeah, you see, this is the risk of 100% MBB, 11.4%. It's actually the same risk with MBB. And this portfolio 100% of GMDF had exactly the same risk with GMDF. But when we combine the two financial assets together, yeah, we create a portfolio that have the risk even lower than the risk of the assets with the lowest risk. This portfolio. Do you find that is amazing? Yeah. And the guy who discovered this won Nobel Prize. Yeah, Harry Markowitz, 1952, with the modern portfolio theory. Yeah, so that is simple, and we are working on the portfolio of two financial assets. Yeah, so if we have the portfolio of 3 assets, 5 assets, and more, the calculation will be more complex. But the same principle, when we combine more assets into the portfolio, we are able to achieve the risk of the total portfolio is lower than the single risk of the assets that have the lowest risk. Yeah. Okay. That is one important point of the portfolio theory. But okay, I don't teach you the portfolio theory. You're gonna study portfolio theory in the course portfolio investment, portfolio management. But here, the portfolio is just, the way, the mean, the intermediate step before we move to the financial model, one of very famous and popular financial model, that is the capital assets financial model that we're going to cover by the end of this chapter. But here, so portfolio is a necessary step in able to understand the capital and assets financial model. Okay, and now I create a figure that I illustrate this column and the standard deviation column. So risk and return. This is the return and this is the risk. Yeah, and this figure is the type of the figure is scatter plot. Yeah, so please, when you do it with your Excel, please find the scatter plot figure. Okay, so in the scatter plot, remember the horizontal axis is the expected return. I'm sorry, standard deviation. Yeah, and the vertical axis is the expected return of portfolio. Yeah. Okay, for each point that it corresponds to each portfolio. Yeah, so this is portfolio A, B, C, D, and E. Yeah, and if your figure, and look at this figure, yeah, is when I combine when I draw the different portfolio on this figure, I can create a line with um, a pullet shape. Yeah, the top of the pullet shape. Cái mũi của cái hình đầu đạn các bạn. Yeah. And if your graph doesn't look like this, doesn't create a curve like this, then there will be something wrong. Yeah. Okay, so make sure that when you draw the combination of each return and risk of one portfolio, and you put them into one graph to illustrate all the allocation of portfolio, then you have this shape, this curve. Okay, so look at this curve. Among the 5 portfolio, which portfolio have the lowest risk? Yeah, you can say this portfolio B. Yeah, so this portfolio have the lowest risk. Yeah, 11% here. And this is the return of this portfolio. Is there anyone want portfolio C? Okay, is there anyone want portfolio C? Wow. Look at portfolio C. Portfolio C have higher risk than portfolio B. Yeah, and the return is even lower than portfolio B. Yeah. So in terms of efficiency, portfolio C is not as good as portfolio B. Yeah. And please remember this. Notice this. In this example, we don't have short sale. Yeah. If short sale is allowed, then we can have negative weight of German debt. For example, I can go for 5%, negative 5% of German debt. So I can extend this table on this side and also extend this table to this another side when short sale is allowed. And when short sale is allowed, actually your figure, the line can be like this. Yeah. And now it becomes clearer that, okay, for example, the same argument with portfolio C, that any portfolio you choose below portfolio B, yeah, have inferior characteristic compared to portfolio B. For example, if you choose this portfolio, yeah, just right below B, this portfolio for sure had higher risk than B and lower expected return. And I can come to you, I say, hey, look, I can offer you a portfolio at the same risk with this portfolio with this. Yeah, the same risk. Yeah, here. But higher return by, I draw like this and it cut the above line at this point. So at this point, okay, I call this portfolio is portfolio, for example, for portfolio F. Yeah, this portfolio had the same return, had the same risk with the portfolio below B. Yeah, but it had higher return, right? So with the same argument, we can come to a conclusion that for any portfolio that below portfolio B, yeah, is yeah, the portfolio are inefficient. Yeah, the portfolio are inefficient because we can always find another kind of portfolio. Yeah, a, a portfolio means a combination between GMLF and MBB. Yeah, a combination between GMLF and MBB. We can always find another kind of combination that have the same risk with higher return or the same return but lower risk. Okay. Okay. So all the choice below B we don't choose. Yeah. And how about the portfolio A? Portfolio A have higher risk than B. Yeah, higher risk than B here. But at the same time, portfolio A also have higher return than B. Yeah, so higher risk is compensated or is rewarded by higher return. Okay, and the same with other portfolio along the above line here. Okay, so by the same argument, I will argue that all the combination from B upward, yeah, are efficient portfolios. Efficient portfolio means the portfolio uh, for the given level of risk, yeah, the portfolio achieve the high return. Or for a given return, the portfolio achieve the lowest level of risk. That is the efficient portfolio. And the combination of the efficient portfolio we call the efficient frontier. So this is the line where I highlight. Yeah, the line I highlight here. Yeah, efficient frontier. Đường biên hiệu quả các bạn ha. Okay, and now for portfolio A and B, maybe you would like to know for portfolio A, we have higher risk, so we are rewarded by higher return. But whether the rewarded, the proportion of rewarded return per unit of risk is high enough compared to portfolio B. So we had to do one step. Okay. Okay, let's do it on Excel. Okay, look at this one. I compute, I take the standard deviation and I divide it for uh, return. Yeah, so I take this ratio. So portfolio A is 0.84. Yeah, B is 0.86. So the highest is portfolio B. This one will be portfolio B. Yeah, portfolio A. And the lowest is portfolio A, B, C, D, E. Yeah, here. Okay. And so what does this number tell us? This number tells us that for a unit return, how many unit of risk you have. How many unit of risk you have. Yeah. And so for 0.84 for portfolio B, yeah, that is the risk per 1 unit of, yeah, I'm sorry, it should be on the other way around. So I take standard deviation divided by expected return, it should be like this. So this number, the lower the better, right? The lower the better. So for between portfolio A and portfolio B, we see that portfolio B have a lower uh, risk reward, lower risk reward, and really better. Yeah. Okay. And look at this figure. Now, if I change the correlation between A and B, between two assets, GMF and MBB, you can see what happened. Okay, now I increase the correlation with, for example, 0.8. Yeah, and you see this curve become flatter. Yeah, and if I increase to the perfect correlation mean 1, then it become a line, a linear. Yeah, so the higher risk, the higher return. There no the portfolio with the lower risk is the portfolio of MBB, that 100% MBB. Yeah, there are no optimal portfolio. uh, I mean, there are no combination between GMF and MBB that have the higher or return for a given level of risk or the lower risk for a given level of return. And now I decrease the correlation for, I'm sorry, I yeah, decrease the correlation zero point 0.1. Yeah, you see this curve become sharper, right? Become sharper. Now the lower risk, the portfolio with the lower risk can be somewhere um, about 9.5%. Yeah, that is the peak of this curve, about 9.5%. And if I change this correlation to zero, then you see it even sharper, this curve. And how about negative? Negative 0.5? Yeah, okay, I had to adjust the graph in order to see the line. This would be for match, um, not for match charge area, but for match this axis. Yeah. So here, remember, this axis A begin from 8%. So now I reset it. Yeah, you see. Yeah, and now the portfolio with the low risk is somewhere between some is about 6.4%. Yeah, and you see the expected return doesn't change, but now the standard deviation of the risk of the portfolio have changed a lot. Yeah, now the low risk is 6.8%, even less risk than the previous correlation. And now I changed the correlation to -1, so negative, perfectly negative correlation. And then, ooh, did you see? And now the portfolio with the low return with the low risk is one, yeah, the risk is about 1.8%, but the return of that portfolio doesn't change. You see, that is beautiful, very beautiful. Yeah, but of course, in order to find the two stock that move in the opposite direction, they very difficult. And so now we can come to a conclusion that the negative, the correlation between the two stock, the less risk of the portfolio of the combination of the two stocks. Yeah. So your job is simply find the two stocks that have less correlated to each other as much as possible, and then you can come with a portfolio with you know the return as you wish, but the risk is as minimum as possible. And why? How? How? Go back to our example. And the question is why the combination of the two stock that can do a miracle job that it generate a portfolio that have the lower risk. Yeah, and why is that? Yeah, because we can buy the stocks, because that is the portfolio. And by combine the two stock or more financial assets in one portfolio, we that action we call diversification. Yeah. So please, portfolio diversification is the investment in several different asset classes or sectors. Yeah. Okay. So diversification is not just holding a lot of assets. So if you own 50 internet stock, mean that 50 stock come from one sector, one industry. That is not diversifying. Yeah. You have to diversify among stock, among different sectors, and among different asset classes. Yeah. Okay. Let's look at table 13.7. Column 1. is the number of the portfolio in number of stock in one portfolio, and column 2 is the risk of that portfolio. So you see, if one stock in the portfolio, then the risk is 49.24%. But when you increase the number of stock, then the risk of the portfolio decrease. Yeah, but notice that the speed of decreasing is not the same, it's not identical, or it's not a constant. Yeah, it's different. For example, from when you increase stock from 1 to 2, then the uh, portfolio risk decrease from uh, this. So the gap between this is about, okay, about 12%. Yeah, and from 2 to 4, it decreased like 8%. Yeah, and this one about 3%, just rule number, 2%. Yeah, and from here to here, okay, 0.86%, 26%. You see, the speed of decreasing is not constant, it decreasing. The speed of decreasing is decreasing. Yeah, so, and then finally when you come up from 50, you double from 50 to 100. Yeah, the risk of the portfolio also decrease, but not as much like before.